Hi, my name is Gdali Garmiza, and I'm the author of the software EarQuiz Frequencies. EarQuiz Frequencies is a free and open-source application for developing and mastering the ability to orally recognize frequency bands. This is an essential critical listening skill for anyone who works with audio professionally or creatively. It allows one to adjust both separate timbres and overall mixes quickly, precisely, and consciously, using audio filters and equalizers according to technical or creative purposes. This application will be useful for audio professionals, tracking, mixing, and mastering engineers and recording producers, live sound engineers, sound designers, and DJs, performing musicians, composers, arrangers, vocalists, and spoken word artists who often work with microphones on stage or in a studio regularly, students and educators in music and sound industry, and also anybody who is interested in learning how to adjust an audio system with an equalizer by ear. When the application is loaded, the Getting Started window appears. You can quickly open the online version of help on your smartphone or tablet by scanning the QR code with a gadget. Before we continue, please like this video and subscribe to this channel. The overall training process involves ongoing learning and testing yourself. Both learning and test exercises consist of audio samples, which we will call examples. Each example is a 10 to 30 seconds long chunk of either pink noise generated on each application launch or music. Technically, any external audio file of a supported format stored locally on your device can be used instead for the latter. So, you could further experiment with recordings of speech, different sounds, natural or synthetic noises, whatever you have in your audio collection. The method behind every example is fairly simple. It begins normally, with no spectral changes. After several seconds, the octave or one-third octave graphic equalizer, which boosts or cuts the amplitude of one or two frequency bands, is switched on automatically. After some more seconds, the EQ is switched off again, and the sound is returned to its normal, non-equalized state. Let's listen to an example with pink noise. For this, pink noise should be selected as the audio source. This is the default setting. And of course, make sure your audio system is switched on and the playback audio path is working properly. By default, the program uses your system sound output device. But you can easily switch to any available audio playback device, selecting Audio Device menu item from the main menu. You can now simply click on the Learn Mode button or change the position of any EQ slider's handle by dragging or clicking on it, which will switch the application to the Learn Mode automatically. Let's take a look how it works. So, we have ensured that the sound is played back. Here we could proceed with the training process, but I suggest that first we should talk about choosing an audio system, adjusting playback settings, and checking whether your equipment is suitable for training purposes. In general, the more neutral the sound and the wider the frequency range, the better. If you can do these exercises in a well-treated room with studio-quality monitors, you have ideal conditions. However, decent consumer systems that do not add obvious distortion, crackling noises, etc. to sound at tolerably loud levels and reproduce a wide frequency range can also meet our requirements. You can use quality headphones as well. It is much easier and cheaper to achieve the accurate sound with them, one of the main reasons being that it is not affected by the room acoustics. Be aware, though, that pitch and loudness perception in headphones may significantly differ from the experience with loudspeakers. And you cannot feel the sound with your whole body this way, which may be especially important for analyzing the lower end of the spectrum. If your audio path contains any tone controls, equalizers, or sound processors, which affect the spectrum of reproduced sound, in most cases they should be switched off or set flat, unless you know for sure that they compensate for the certain flaws. If you have the loudness compensation button on your playback preamp or receiver, it should be off as well. Now let's set the optimal audio playback level. We should immediately stipulate that it may differ for different audio sources, EQ patterns, and settings. However, it is highly undesirable to change the volume during or between separate examples of the same exercise. since our frequency perception is heavily influenced by the sound level due to the laws of psychoacoustics. We'll take the first pattern with pink noise as the audio source for a while. We start the playback in the learn mode, and we set the volume to the most comfortable or tolerably loud level. There is a volume slider inside the application, which can be accessed from the transport panel. It has a logarithmic scale. The level indicator shows both the slider position in percent and the relative amplitude level in decibels. It is set to 60% or minus 14 dB by default. Also pay attention to the peak normalization level shown in the status bar. Peak normalization of an audio file or its part is a linear change of its whole gain that makes the amplitude level of its PCM sample with the maximum amplitude equal to a certain value. In this software, normalization is applied automatically to prevent digital clipping when boosting frequencies. The higher the frequency gain, the lower the peak normalization level, and the quieter the source before the equalization, and vice versa. Now, without changing the volume level, let's test the frequency range of our audio system. We switch the audio source to audio file playlist. The program will automatically go into preview mode. To generate the calibration test audio file, we select File, Make and open Calibration Sine Waves file from the main menu. The application will create an audio file with the sequence of 5 sinus tones with different frequencies, lasting 5 seconds each and separated by 1 second of silence from each other. There is the timeline table in the help file to make it even clearer and easier to use. If we want to know the location of this or another file in the playlist, we right-click on the corresponding file name in the playlist and we select Show in Finder on macOS or Show in Explorer on Windows. In the preview mode, we start the file playback. It has been cycled because the loop playback option is activated. Let's uncheck it. You should be able to hear the first 3 tones, 1 kHz, 10 kHz, and 100 Hz, clearly. If they vary in loudness, it is not a problem unless this difference is too big. If you cannot hear one or more of these, you have a serious issue with your playback system, which must be resolved before going on. In case only the last 2 tones, 15 kHz and 40 Hz, are barely audible or even inaudible, you can proceed. But be aware that you may have difficulties hearing or identifying the low or the high extremes of the spectrum correspondingly. Before going into learning and test exercises, we'll make a short review of the equalization patterns these exercises are based on. There are 15 presets with increasing difficulty in the application, and I recommend passing them exactly in the same order, first on the pink noise and second on music and other audio material. Let's take a quick look at what they are. In the first 3 presets, we deal with boosting 1 octave frequency bands within the low, middle and high ranges separately. The presets from the 4th to the 6th are similar, but the frequency bands are cut instead. The 7th to 9th patterns use the full frequency range, divided into 1 octave bands as well. In the 9th preset and further, both options are used. And starting from the 9th pattern, the tests require not just guessing the frequency bands, but also whether they are boosted or cut. In the next 4 presets, from 10th to 13th, the 1/3 octave equalizer is used. It has 30 sliders, but the 25 Hz and 20 kHz sliders are permanently disabled. since these frequencies are at the boundaries of our perception and most systems' reproduction. The 10th pattern deals with low frequencies, the 11th one with middle frequencies, and the 12th one with high frequencies. The 13th preset uses the full range. In the 14th and 15th patterns, two frequency bands are treated at once in each example. Two frequency bands are both boosted or cut, or one is boosted and another is cut simultaneously. In the 14th preset, the 1-octave 10-band equalizer is used. And in the 15th pattern, the 1/3 octave 30-band EQ is employed. Now we'll go back to the first preset and try to do the exercise on pink noise. We switch to the Learn mode. So, 31 Hz. Even when reproduced through high-quality audio systems, this area is more felt than heard. If we want to repeat the current example, we click on the play button or press the space key on the keyboard. To move on to the next example, we should click on the next button with the right arrow. It was 63 Hz. On audio systems with a wide frequency range, a very low hum is clearly heard. "125 Hz is a powerful low-frequency boom. "250 Hz is the area between low and middle frequencies, and it sounds like the vowel oo. "500 Hz is the middle frequency band. It sounds like oh. Now let's take a test. We choose the answer. If we now press the play button, the same example will be repeated. But to go to the next example, you should press the next button. So, we have perfectly nailed this exercise. We got a score of 100 out of 100. The next pattern is the middle 5 one-octave bends boosted. And here is where the associations with vowels work best. So let's repeat. 250 Hz boosted sounds like oo. $500 boosted sounds like oh. One kilohertz boosted sounds like ah. Two kilohertz boosted sounds like eh. Four kilohertz boosted sounds like e. Now let's repeat the whole sequence. But we will check the sequential playback option for convenience. In this case, in the Learn mode, we don't need to click on the next button after each example playback. We can start the playback once and listen to all the possible options instead. Moreover, in addition to ascending order, you can optionally change the equalizer band's playback order to the descending or to the shuffle one. For this, select the appropriate option in Controls, EQ bands order in Learn mode menu of the main menu. We choose the descending option, and we drag the slider with the highest frequency of the current range. In this case, the program has stopped the playback after all possible options within the current EQ pattern have been gone through. But it is possible to make this loop infinite by checking Controls, Loop Sequence of EQ bands in the main menu. Then the playback will continue until a user stops it manually. Well, let's try to pass the test. Excellent! 100 out of 100. And now the third pattern, the highest 5/1 octave bands boosted. Let's try to play back the frequency bands in shuffle order. We choose Controls, EQ bands order, Shuffle in the main menu. We launch the Learn mode. And now the test. We've coped excellently here as well. Now, let's get into working with audio files. But we will save the volume level setting before that. We'll right-click on the volume slider, then choose Save Volume Level. Now, before loading mastered music tracks with maximized levels, we'll reduce the volume by 10 to 15 dB. There are different ways to load external audio into the application playlist. You can select File, Open Files from the main menu, or press Ctrl-O on Windows or Command-O on Mac OS, or click on the plus button in the audio source window. You can add the whole folder by selecting File, Open Folder from the main menu. Alternatively, you can drag and drop files or folders to the playlist from a file manager or any other application that supports this feature. Let's find out which types of files and extensions are available for loading: WAV, AIFF, MP3, FLAC, and OGG. You can add audio files of the supported formats to the application playlist directly or through playlist files. Currently, the program can parse M3U, M3U8, PLS, and SPIF playlists. So, we have added files to the application in one way or another. Now, we'll listen to them in the preview mode, and we'll select and trim regions for training. The active part of a loaded audio file, from which training examples will be sliced out, is shown as the white zone of the audio timeline slider at the transport panel, and the gray sections represent the unused parts before and after that. By default, each region starts at 0 and its length is equal to slice length of each future training example, multiplied by 10 or by a smaller maximum number, which can fit the length of a track. A slice length can be set for each audio file individually. If the pink noise is selected as an audio source, the slice length setting is applied to the pink noise examples. If we want to fix the current slice length as the default setting for the pink noise or newly opened files, we click on the star with the audio source selected correspondingly. But let's go back to working with audio files. You can set the starting and ending points of the active region of an audio file in different ways. You can move the left and right bounds of the region separately, and the whole region as well, by dragging the mouse cursor. The start or end values can also be set or adjusted manually with the corresponding spin boxes. There are also 4 auxiliary buttons. Clicking on the start and the end buttons on the left sides of the spin boxes would set these values to the current audio cursor position, if possible. In the preview mode, you can move the cursor and therefore change the playback position when listening to audio files. However, it is frozen when doing exercises. If the loop playback option is checked, the playback of the current region is cycled in the preview mode. The cursor reaches the end of a region, and the playback repeats from its start. Otherwise, when reaching the end of a range, the playback is stopped. But let's go back to the buttons, which adjust the playback region boundaries. With 2 other buttons on the right sides of the spin boxes, you can set the starting point to the beginning of a file and the ending point to the end of a file respectively. Clicking on the clear button at the right of the start or end spin boxes resets the region bounds to default for newly loaded files and restores the previously saved values for already known ones. The bounds values of regions and the slice lengths are stored for each audio file on another file load or when the application is about to be closed. This is how we make the collection of audio excerpts for our exercises.
Built on love, built on talent, built on love, built on talent, built on love for each other, acceptance. Give them love, give them love. Don't matter what you look like, don't matter what you need, but just believe in love.
Before getting to training, it is worth unchecking the Controls, Start Playing after loading track in preview mode option in the main menu if checked. Otherwise, on each track loading for an upcoming exercise, it will be played back automatically in the preview mode, which may be quite irritating. Now let's restore the volume level that we've set for the training, learn and test modes. We right-click on the volume slider and select Restore Volume Level in the context menu. The most effective learning approach would be applying to already prepared music material all those patterns that we have already used on the pink noise. We will take as an example the track called Believe in Love by White Ocean, who is the producer and DJ from South Korea. The saxophone part is composed, performed and recorded by me. Here we won't go through all the patterns for time-saving purposes. We will take only the second one for shortness instead. This is the middle 5-octave bands boosted, starting with the learning examples. So we activate the learn mode. Now we'll pass the test. Oops, we're wrong by 1 octave. We'll listen to this example once again. One octave error again, listening. We'll look at the mistake. But in general, we have coped with it rather successfully. The next pattern group is devoted to cutting 1 octave frequency bands. They should be fully passed as well, in the same order they are presented. But we will take the preset number 5 as an example, which is the middle 5 1 octave bands cut. Starting with the learning exercises on the pink noise. Now the test. Let's replay. And now we'll do the exercises on music with the same pattern. We'll take the track by my friend and client Albert Lucero from the USA as source material. I recorded my saxophone here as well. And the track is called You're My Star or Tu Eres Mi Estrella, starting with the learning mode. And the test. Let's sort out the exercises where frequency bands can be both boosted and cut. We'll take pattern number 9 as an example, all 10 one-octave bands. Starting with learning exercises on the pink noise. For learning exercises where frequencies are both boosted and cut, in addition to selecting the ascending, descending, or shuffle order, the choice between two more options is actual as well. The first one is each band boosted then cut or vice versa, which is the default option. Here, each frequency band is first boosted then cut, or conversely, first cut then boosted before proceeding to the next one. And the second option is all bands boosted then all bands cut or vice versa. When it is checked, all the currently available frequency bands are first boosted, then all of them are cut in the same order, or vice versa, first cut, then boosted. Now let's have a test. And now the same ninth pattern with music. This track is called Collusion. It is produced by Kevin Swisher, who is my friend and client from the US as well. Here I also performed and recorded the saxophone part. And for learning exercises, we'll choose the order all bands boosted, then all bands cut, or vice versa. Now the test exercise. Well done! Now some learning examples with 1/3 octave frequency bands. In EQ band's order in Learn Mode settings, we choose Shuffle, each band boosted then cut or vice versa. Pink noise first. Now we'll load a track from the YouTube collection. And some learning examples on music. I suggest that you learn in more details and do similar exercises on your own. Now we'll look at the exercises with two frequency bands treated simultaneously, which are proposed in the 14th and the 15th patterns. So we choose the 14th preset. Two 1-octave bands treated, each one boosted or cut with 10-band equalizer. We are not going to listen to all the possible combinations because it will take too much time. Instead, with shuffle order option checked, we'll listen to some learning examples with randomly chosen frequencies. Starting with the pink noise. As with other patterns, here you can choose manually, with sliders, what frequency bands would be boosted or cut in an upcoming example. To prevent mind games fooling your ears and brains, in dual band exercises the use of adjacent frequency bands is intentionally avoided. That's why, when one slider is moved, the neighboring sliders are disabled in both learning and test modes. Until the second frequency band is selected, you can change your mind, setting a slider to the neutral position. Now let's pass the test. Let's try to do similar exercises with music. And we'll take the track Believe in Love, created by White Ocean in collaboration with me once again. Let's listen to some learning examples. And we'll try the test. The 15th pattern is similar to the 14th. Here two bands are boosted or cut simultaneously as well, but with 1/3 octave resolution using 30-band equalizer. We'll listen to some learning examples on the pink noise. And now the similar learning examples, but on music from the YouTube collection.
At 29 and I find myself wondering what did happen to the last 10. I ran away with my life, fast forward, never turn back again. It's kind of funny that the more we pass time, the more we need to set them rewind. And 19 was the year I had to leave you, but now I'm seeing all the signs. Is this really happening? I can't believe it's true. I'm just as surprised as you. Is this really happening? I can't be too sure, but one day I'll be yours again. Life lessons come one in a dozen. The other 11 get something from nothing. I sit here looking for an answer. Maybe the biggest question was in the last chapter. You gave me the soul I have today. Without you I never could have moved away. But now I seek what you teach. I do believe I always should have stayed. Yeah. Is this really happening? I can't believe it's true. I'm just as surprised as you. Is this really happening? I can't be too sure, but one day I'll be yours again. One day I'll be
Equalization settings. Equalizers in the application are sets of picking or bell band pass filters with determined center frequencies, with a distance of 1 octave or 1/3 octave between them. In the equalization settings, two parameters are present: frequency gain, which determines the amount by which the center frequency of a filter is boosted or cut, and bandwidth, which is used to set the width of a boosted or cut frequency band. Each pattern includes both of these parameters, but they can be manually adjusted as well. You can set your custom options in the preview mode or in the learn mode between playbacks of examples. In the test mode, these parameters are disabled because it is important to maintain the same settings between different examples of the same exercise. The frequency gain parameter is always an integer between 1 and 18. It determines the equalization depth, the amount of dB by which frequency bands are boosted or cut. Therefore, the lower this value, the finer filters affect a spectrum, and the harder it is to identify those changes by ear. As mentioned before, the program applies out-of-peak normalization to an audio signal ranging from -1 to -21 dB. There is an inverse relationship between equalization depth and peak normalization level. For dual-band EQ patterns, there is extra headroom from 1 up to 3 dB. Let's explore the change in equalization depth using one music excerpt as an example. Filter bandwidth, which is the second parameter, is usually measured in octaves. To understand what this value means, let's take a look at a filter frequency response scheme. There is the center frequency, which is determined by the choice of an EQ slider in the application. It is the most altered, boosted or cut point within the frequency band. If we draw the horizontal line at the 3 dB roll-off point, which is the 50% drop in power or energy, we'll get 2 points at the crossings with the filter curve, one on the left and another on the right. The absolute bandwidth in Hertz is the difference between these two frequencies, the highest and the lowest ones. Dividing the center frequency by the absolute bandwidth in Hertz, we get the value called the quality factor or Q factor of the filter. This is the most commonly used value in equalizer settings. And as we can see, the Q factor is inversely related to bandwidth. The bigger the Q, the narrower the band. The wider the band, the smaller the Q. One can convert an absolute bandwidth value in Hertz to a relative bandwidth value in octaves with formula, logarithm of f2 divided by f1 with the base of 2. This is the value used in equalizers and in our application as well, because it remains constant no matter the center frequency. For bandwidth options, I have used values that can easily be thought of as music tempered scale intervals. Let's take a look at the table in the help. The narrower or steeper the filter curve, the more accurately and precisely it works. The wider band, conversely, affects more frequencies and makes equalization more prominent but less exact. With too high Q factor, the situation where there is no audible content in a particular part of the spectrum is more likely, especially in music. With too low one, the boundaries between frequency bands may become blurred. To compare different values of this parameter, we listen to the equalization of the pink noise with the same frequency band boosted, but with different Q factors and bandwidths. We set the maximal frequency gain level, 18 dB. When the Q factor is high, the filter literally sinks at its center frequency. For presets with 10-band EQ, I have set the default bandwidth to 1 octave with ±12 dB gain. And for those with 30-band EQ, I have used the 1/3 octave value with ±15 dB gain. The presets change equalization settings only when the lock is opened. If the lock is closed, the current settings stay the same across various EQ patterns. By lowering the frequency gain level up to ±1 dB and making bands extremely narrow, you can increase the difficulty of exercises using the same stuff. Playlists. Basically, within the software, the single playlist is used. You can add the tracks you are going to use as audio sources for your exercises to it, reorder them, and remove them. The playlist contents are saved and restored on each program startup, unless cancelled by user. You can also export them to separate playlist files, which is highly recommended every time you make a collection of tracks that would be reused in the future. Different ways can be used to add audio tracks into the application playlist. You can click on the plus button or select the same option, File, Open Files, from the main menu. You can also choose the folder with audio files, selecting File, Open Folder from the main menu. If the application is not opened yet, you can alternatively select audio files in File Explorer on Windows or Finder on macOS and use the Open With option in the right-click context menu to open them with EarQuiz frequencies. But perhaps the simplest way is to drag and drop files or folders to the playlist from a file manager or another application that supports this feature. This could be your favorite audio player. The program will also search for audio files and parse the playlist files of supported formats in all the dragged and dropped folders and their subfolders. Currently, the application can read playlists with M3U, M3U8, PLS, and SPIF extensions. The playlist widget is a table with 3 columns: file name, duration, and folder path. The audio items, which can potentially be opened, have normal black font color. If an error occurred while trying to read a file or load it to the player, or its duration is less than 10 seconds, or its sampling rate is lower than 44.1 kHz, it would be colored gray. If a file, having already been added to the playlist, cannot be found anymore, it becomes red. To show any of the tracks from the playlist in File Explorer on Windows or Finder on macOS, select and right-click on it, or select it with right-clicking and choose the corresponding option in the context menu. You can remove the unavailable gray and red tracks, selecting Remove Unavailable from the right-click context menu. To remove certain tracks, select them and click on the minus button, or choose the Remove Selected option from the right-click context menu, or press the backspace or the delete key. Clicking the Clear button above the playlist removes all the items from it. You can change the items order with the internal drag and drop of the playlist. You can load any track you want just by double-clicking on it or by selecting it and pressing Enter. If the pink noise is selected as the audio source, this will set the audio source to the audio file playlist mode automatically. And the preview mode would be switched on as well. The next or previous track can be loaded with the corresponding buttons on the transports panel. There are also similar next and previous track buttons above the playlist. When you are not in the preview mode, the player skip controls or buttons are not available though. In this case, if you want to go forwards or backwards in the playlist, you can still use the navigation buttons above the playlist to quickly load another audio file. This will switch the program to the preview mode, whatever the current mode is. Any learning or test exercise would be cancelled. Moreover, any change of audio source resets the application to the preview mode. If you want the files to be selected randomly instead of the current order when moving forward, check the Shuffle option. If the playlist contains tracks that cannot be loaded, in most cases it is worth activating the Skip Unavailable Tracks option. Then, during the navigation process, gray tracks will be skipped. I remind you that you can also delete them from the playlist by selecting the Remove Unavailable option in the context menu. To export your playlist contents to a separate file, select one of the 2 items in the File, Export Playlist menu in the main menu. The first one is Export with Absolute Paths, and the second one is Export using relative paths for subfolders. In the first case, all the saved paths will be absolute. This is suitable when you are going to open the audio files from the same machine without changing their location or renaming drives, parent folders, etc. The playlist file itself can be stored locally anywhere. In the second case, the paths to the audio files in the same folder as the playlist file or below would be stored as relative ones to the playlist file path. This option is preferable if you want to make a movable library of audio sources and organize it with playlists. You should have a separate parent folder for such a collection, of course. Let's conduct an experiment. We'll save the playlist as 2 files, one with absolute paths and the other with relative ones. Then we'll move the folder with audio files and playlists to another place. Here, this would be the desktop. And we'll try to load each of these playlist files. When trying to load the file with absolute paths, nothing happens. But the playlist file with relative ones is loaded successfully. Currently, you can save your playlists as M3U or M3U8 file. These are very human-readable text file formats, which may contain only audio file paths or URLs at different lines. The only difference between them is that M3U8 forces the use of UTF-8 encoding. On macOS, you can use them interchangeably, but on Windows, the system encoding, which may be different, is used for M3U files, which may cause problems with non-Latin characters. So M3U8 is more recommended in general case, and it is set by default. Converting audio files formats. With the use of the in-app conversion tool, one may want to achieve two goals. The first one is to convert audio files of compressed formats with playback issues to stable, uncompressed formats, or to resample audio files with unsupported sampling rates to supported ones. And the second one is to diminish the file size with downsampling. To convert audio file or files, first select it or them. Second, choose the file, convert selected files item from the main menu, or the same option from the right-click context menu of the playlist. In the opened dialog menu, you can choose the output format, WAV or AIFF, and the action to be done with sampling rate. As for the action with the sampling rate, here you have 4 options to choose from. The first one is same as original. It means that the source files are not resampled. The sampling rate of output files is equal to the sampling rate of input files. With the second and third options, you set the sampling rate of the output file to 44.1 kHz or 48 kHz respectively, no matter the source sampling rate. But the fourth option needs some explanation. It senses to lower the higher sampling rate, preserving quality as much as possible. Files with a sampling rate of 44.1 kHz or 48 kHz are not resampled. The sampling rate is lowered in the gentlest way when the source value is divided by an integer, or in other words, when each second, third, fourth sample and so on is left. So, if the file sampling rate is 44.1 kHz or the multiple of 44.1 kHz, 88.2 kHz, 176.4 kHz, etc., the output sample rate is set to 44.1 kHz. If the file sampling rate is 48 kHz or the multiple of 48 kHz, 96 kHz, 192 kHz, etc., the output sample rate is set to 48 kHz. When the original sampling rate of a file is changed, it is labeled as resampled in the output file name. After checking out or adjusting all the settings, press the Convert button to proceed. When done, the new file or files would be added to the playlist after its or their source file or files. Known issues with audio file formats. The current version of the application uses the system backend for audio playback. One of the issues both on Windows and Mac OS is the absence of OGG files playback support. Nevertheless, they can be added to the playlist. But if you try to load an OGG file, you will get the error message with option to proceed with conversion to another format. There are minor issues which may cause some inconvenience as well. For example, the non-correspondence between the real and shown playback positions of FLAC files on Mac OS. It may occur when playback is started from a non-zero position. In this case, you can also make consistent WAV or AIFF files using the in-app conversion tool. Making training audio files. The application allows you to create your own learning and test exercises in the form of audio file collections. The possible export formats are WAV, AIFF, MP3, FLAC, and OGG. So you can use them either for self-studying or teaching, even without this application, just with any playback device or software which supports these common audio formats. To make learning or test exercise audio file collection, select File, Make Learning Files, or File, Make Test Files from the main menu correspondingly. Both options call the same dialog window, but with different type settings selected, which can be changed afterward. For the exercise files, the current audio source, EQ pattern, and EQ settings will be used. The default parent output directory, exercise folder, is Documents, EarQuiz Frequencies, Exercises, in the current system user folder, but the dialog has an option which lets you change it. By default, for each new exercise, a new subfolder with exercise name is created, and this name is used as the prefix of each name of exported files. But you can switch off these options by unchecking the Use as folder name or Use as prefix of file names settings. A default exercise name is generated automatically on each dialog window call, starting with exercise 1 and increasing the ending number, exercise 2, exercise 3, etc., as needed so that the name would not repeat the name of an existing folder. The number of learning audio files equals to the number of possible equalization options or combinations within a current EQ pattern. The applied equalization, sensor frequency, boosted or cut is indicated in the learning audio files names. The order of EQ bands is determined with the current settings of the controls, EQ bands order in Learn Mode menu of the main menu. The examples are enumerated by default, but you can deactivate this option by unchecking the Enumerate Learning Examples option. The number of test audio files in an exercise is always 10, and the examples are always enumerated, but you cannot get the answers from the file names. There is also a text file added to audio files. In case with learning exercises, info.txt includes the common information, audio source information, EQ pattern, EQ settings, peak normalization level, etc. The text file answers.txt of a test exercise collection in addition provides the right answers. The sampling rate of exercise audio files is the same as the sampling rate of the audio source they are made from. The default bitrate of lossy formats, MP3 and OGG, is 320 kbps, but you can choose another one from the corresponding box. After checking out or adjusting all the settings, press the Make button to proceed. And at the end of our video tutorial, we will talk about the storage of application data and settings. I tried to make the program store all its data and settings in one place, without leaving a lot of scattered garbage on disk or in registry on Windows. On macOS, the parent data and settings directory is Library, Application Support, EarQuiz, Frequencies under Current Systems User folder. On Windows, it is located in EarQuiz, Frequencies folder under the current user's application data folder. Therefore, by manually removing it or some parts of it, you can reset the corresponding settings to defaults. Moreover, automatic cleanup of all the application data during the uninstallation process, which is often not desirable, becomes unnecessary. The config.ini file contains the program settings and states, including checked or unchecked options, windows or panels sizes, placements and visibilities, last used audio source and EQ pattern, locked EQ settings, etc. The audio tracks paths of the current playlist are stored in current.m3u file inside the playlist subfolder. The trimmed ranges, starting and ending points, and the slice length values of audio files are stored inside the source range lib subfolder. Each loaded audio file is hashed, and the data about each audio file is saved as a separate JSON format file, with the name of MD5 hash sum of the corresponding audio file, and the AFAB audio file AB extension. You can also see the audio file name inside each of these JSON data files. Hashing big files is not a very fast process, but this method allows the program to identify files in a path-independent and platform-independent way. That said, you can even transfer these AFAB files to a similar folder on another computer, and the copy of the application running on that machine would be able to apply these settings and data to the identical copies of your audio files. That's all. If you want to support this project, please like and share this video with your friends. And I would appreciate any donations through any method available to you. You can find the links to the Buy Me a Coffee, Patreon and Boosty pages in the description. The donation and share buttons can be found inside the application as well. Even the small recurrent donation to the project not only helps to support and develop the software, but it is a great source of additional motivation for you to keep practicing. Enjoy your training and have fun!